a repeating decimal to a fraction. We're going to take 0.4 repeating. The 4 continues. The main crux of this, what we're going to do is we're going to take this part of the decimal. Keeps going in for eternity. We just want to bring part of it over to the left-hand side. Let the rest of the repeating stay to the right. Then eventually what we're going to do is cancel out the repeating portion. So that's the main intent of this. So here's how we're going to do it. We're going to say x equals 0.444. Going on into an infinity. Now, in order to get one of these digits to the left, we have to multiply this by 10. So we're going to get 4.44444, repeating on into an eternity. Change sides, okay. If we had to multiply this by 10, you have to multiply the left by 10 so this stays equal, correct? So what you do to the left, you have to do to the right. So instead of being 1x, this becomes 10x. Okay. Everybody clear on what I did? I went from here to here by just multiplying this by 10. This brings one of the repeating digits over to the left. And the remaining part of the repeating digit stays to the right. Now I'm going to subtract these two from each other. If I subtract 10x from 1x, what do I get? 9x. So I got 9x here on the left. Now on this one here I got 4 and I got a 0, and then the repeating on the top number as well as the repeating on the bottom. These two are going to cancel out, right? So that cancels out. The only thing we get here is 4 minus 0, which is 4. So we got 9x equals 4. Well, we want to figure out what the x is, not the 9x is. So what do we have to do here? Divide both sides by 9. This cancels, so on the left here we're going to have x equals 4 over 9. Can we reduce that?
No.
So that's in its simplest form. So somebody check, divide 4 by 9 and see if you get 0.4 repeating. See if that. Let's try this one here. This time, the first digit doesn't repeat. The second digit repeats. Okay. So in this case, we're going to have to get 2 digits over to the left, because we've got to get one of the repeating digits over to the left. So let's just say x equals 0.16 repeating. Now, we've got to get 2 digits over. I should have wrote this lower. All right, let's start out this way. X equals 0.16 repeating. We want to get, for our subtrahend, or what we're going to subtract away, we want to first get the 1 to the other side. So how do we do that? Multiply both sides by 10, right? So 10x equals 1.6 repeating. Now we're going back to that situation. This is the one we're going to work with, because now we have 1 digit to the left that's not repeating. We want to bring 1 digit to the left that is repeating. So this is going to be subtracted from the digit with the 1 and the 6 over here to the left-hand side. So let's say 100x equals 116.66666, repeating on. We want to subtract this from this. So let's take 10x here, and this is going to be 1.666. Okay? Now, bring it over here. We'll subtract those two from each other. Now here. Well, technically, we have to bring 2 digits over. So my first pass is I just want to bring the 1 over. So that's what I did here. That's why it's 10x. Over here, it started repeating right away. So we had to bring 1 over. With this one, since they had 1 digit that doesn't repeat and 1 digit that the second digit starts repeating, we got to bring 2 over. So we went from.
But how did you get the 10x, the first one?
I went from here. I wanted to get just the 1 over in one step. So I multiplied this by 10 and this by 10. That brought the 1 over. Now I got the 6 repeating to the right.
So
Go ahead.
would it, I think they're wondering where you're getting the 10 altogether. The 10ths, 20ths, 30, like that?
Yeah.
Depending on how many numbers you got,
Yeah.
is how many zeros you go.
Every time I move the decimal one place to the right, that's the same as multiplying by 10.
Because the
This is
10s,
times 10,
hundreds, thousands.
that would be times 100, the next one would be times
Yeah.
1,000. That's
Yeah.
what that's actually doing.
Yeah, okay. Just wanted to make sure. All right.
You can't see. You can see now? All right, so now what do we have to do? We have to subtract this from this and this from this.
Okay, so
We got 100x and 10x, right? We're subtracting 10x, so this would be 90x.
90x, yeah.
This would be equal to, well, the repeating portion of both digits is going to cancel each other
Cancel
out.
right out, yeah.
So now we got 16 minus 1, which is
15.
15. So
Okay.
now this brings us back to this format here.
Right, right.
Now, we want to get x by itself. We want to isolate the variable. So let's divide both sides by 90. If we do that, this will cancel. We'll get x equals 15 over 90. What do we have to do? Yeah, we simplify. Well, this ends in 5, this ends in 0. We know 5 will work. Anything else work?
15.
15, yeah. So let's divide both by 15. And this is going to equal 1 over 6. Somebody with your calculator, divide 1 by 6 and see if you get 0.16 repeating.
Yeah.
What's that?
0.1666.
Well, that's what I meant.
Yeah.
0.16 repeating. Everybody clear on that?
No, I'm still confused when you have two steps with this one and not the other one.
All right. This one here started repeating immediately. What we're doing here is when we're subtracting these two out, we want something to the left, and we want to get rid of all of the repeating digits. That's the only reason we're sending someone to the left side of the decimal. Since this one started repeating on the first digit, we only had to bring 1 over. Over here, we had 1 that wasn't repeating, so we had to bring that over first. That's why we got this. And then we had to bring 1 over where the 6 goes to the other side, the repeating decimal.
Oh, so when you bring it over the second time, you still count the one you brought over
Yeah,
before.
you still count it. Because technically, this is 10x, and if we move it over 1 more, that'd be 100x. Every time you move it to the right 1, that's 10 times. So it's 10 times 10, which is 100. Does that make sense?
Yeah.
How many people can do this on the next test successfully?